Hello. Can you hear me?
Yes, sir.
Okay, thank you. Hello, can you see my screen? I have shared the presentation slide. Can anyone see? Hello,
Yes, sir.
Yes,
can
yes,
you
yes, sir.
see
Yes,
my
sir.
presentation slide? Okay.
Yeah, explain.
So we'll wait for 5 minutes more, then we'll start at 7:10 p.m. Hello everyone. A very good evening to all. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So I am one of the three PMRFTAs of the course Experimental Physics, which is being flowed by NPTEL in this July 23 session. So basically, I'll be taking session on every Saturday from 7 p.m. to 9 p.m. where we will be discussing few problems regarding the current week lectures that will eventually help you to solve the assignment problems that you will be solving for completion of this course. So the week one in this interaction session, we'll be covering topics taught in week 1 of the lecture series. So week 1 basically it was mainly based on basic tools and apparatus which we will be using during the experimental period. So that include mechanical tools like nuts, bolts, washers, screws, nails, wrenches, screwdrivers, and soldering station, which is used for different type of different to solder different things. And it consists of irons, solder, flux, and wet sponge. Iron is to melt the solder, and with the help of flux, we use flux in order to make oxidation, and the wet sponge is used to clean the iron. And in the next session and in the next week, in the next lecture, you know about meter scales, slide calipers, screw gauge, and galvanometer. So today we'll be discussing a few problems regarding the slide calipers, screw gauge, and the initial measurements. So I think everyone of you must have seen this meter scale. So here I have shown you 2 meter scales. The first one is, as you can see, in the first meter scale, between 1 and 2, as you can see, between 1 and 2, there are 10 divisions. So the least count of this scale is 0.1 centimeter. That is 1 millimeter. But if you see the below one scale, then in between 1 and 2, there are 20 divisions. So with the help of this scale, we can measure 0.5 mm or 0.05 centimeter. So these are the two scales, and least count is basically what we call least count. Least count is the minimum measurement that we can made with the help of this measuring device. So in the upper scale, we can measure minimum of 1 millimeter, but in the lower one scale, due to its precise marking, we can measure more precisely, and the least count is less than that of the below. And also, I request everyone to mute themselves. Please mute your mics. So you must have also come across significant digit and output digit. If you see in the above one scale, in this above one scale, this scale, there are no other measurement marks between 1 and 2. So if you want to measure the length of this pin that is shown in the figure, if you want to measure the length of this pin, so the measurement in the upper scale is lying between 2 and 3. So here, if someone asks what is the length of this plastic pin, so we can say it is somewhat lying between 2 and 3. So we may write it 2.3 or 2.4 centimeter. But here if you see, this 2 is this 2 has certainty because the length is crossing the 2. But since in between 2 and 3 there are no other marks, so we can say that this 0.3 or 0.4 is doubtful digit in this case. But however, in the second scale, in this one, if you see in between 1 and 2 there are 10 divisions. So here if you see, it will be 2.3 for sure. But if the measurement lies between 3 and 4, then it will be 2.33 or 2.34. So here, this 4 is doubtful digit, and all these three are significant digits. So there are different rules also for significant figures and doubtful digits. For example, rule 1, we will be solving few examples regarding these rules. So let's solve our first problem of the session. And the question says, the is diagram to report a measurement to the proper number of significant figure. So in this figure, as you can see, there are two measurement devices. One device shows the measurement, and another device also. This is the object, and this device is measuring the object. So can anyone tell me what will be the value of the two measurements in these two cases, A and B?
Sir, we cannot see the picture completely. Only a part of the figure is getting.
Sorry?
Sir, only a part of figure is getting, not the complete picture. You have to just make the picture to more down.
Can
Yeah,
you
now.
see the picture now?
Yes. Now it's okay, sir.
So there are two figures, and we have to say the measurement value what these figures are showing. So in case of A, this A, the measurement device is measuring in PSI unit. So can anyone tell me what is the PSI is the unit of which measurement, which physical quantity is measured in terms of PSI? So PSI stands for Pascals per square inch, and it is basically a measurement of pressure. So if you see in the arrow mark is between 4 and 5. So between 4 and 5, it is divided into 10 equal parts. So the arrow is slightly above 4.3. So we can write here the measurement is 4.3, which are certain. But however, since the arrow is between 3 and 4, so we can write it either 4.3 or 4.33 or 4.34. Suppose we are writing it 4.33, then the first measurement will show us 4.33 psi. So here in the measurement, all the three digits have significance, but the last digit, that is is the this 3. Since we can't measure it with accuracy, it is the doubtful digit. And in case of B, now as you can see, the measurement gives the value of 1.2. So this is 1.2, and the line lies between 2 and 3. So we can write it as 1.25 centimeter. So since in this scale, the least count of the scale is 0.1 centimeter. So 1.2 is of certainty. However, when we are writing it 1.25, this 1.2 reading is of certainty. However, when we are writing 1.25, this 5 is the doubtful digit. Is there any issue with this problem, or do you have any doubt? Hello? Does anyone have any doubt? Requesting everyone again, please mute their mics. So now let's discuss the second problem of the day. Now the question is, give the number of significant figures in each and identify the rule used for each conclusion. So number of significant figures, we have to determine the number of significant figures in each case, and we should also state the rule used for this conclusion. That is why we are telling this number of significant digit this measurement has. So now talking about A, can anyone tell me it is written as 5.87? Can anyone tell me the number of significant digit in this case?
So it is 3.
Sorry? Once again?
So it is 3.
It is in this case, right? In this case, it is 3. So the number of significant figures in the A is 3 because as you can see, they are all non-zero digits. So according to the rule, there are different rules like I mentioned here. All non-zero digits in the measurement are significant. So in the reading 1, which is given as 5.87, since all the digits are non-zero, so the measurement has 3 significant digits. That is 5.87 has 3 significant digits. So next come to B. So it is written 0.031. Can anyone tell me what is the number of significant digits here and what are they? So if you see the rule here, it is written zeros that appear before the first non-zero digit in a number are called leading zeros. Leading zeros are not significant. So in a decimal number, if there are leading zeros, then these zeros are not significant. So in case of B, it is 0.031. So only these 3 1 have significance. These 2 zeros have no significance. So the answer will be 2. And C is 52.90. Here, as you can see, there are no leading zeros. There are zeros after the reading. So 50 in 52.90. When we are talking about the number of significant digit, it will be how much? It will be 4. All digits like 5, 2, 9, 0 or all have significance and they are significant digit. Here there are only 2 significant digits, 3 and 1, and here these are 5, 8 and 7. And now D, it is 0.2001. So as you can see, this 1 0, this is a decimal number, and this 1 0 is before the non-zero digit 2. So this 0 has no significance. So it is not a significant digit, and these 4 are significant digits. So in D, there are 4 significant digits. These are 2, 0, 0, 1. And in E, so what the rule says. So if you see the rule, it is given zeros that appear before the first non-zero digit in a number are called leading zeros and they are not significant. Zeros that appear after the final non-zero digit in a number with an unwritten decimal point are not significant. So if you see the rule 6, this rule, zeros that appear after the final non-zero digit in a number with an unwritten decimal point are not significant. So as you can see here, 620 has 2 significant figures. So similarly, we can say that in 500, since there are no decimal numbers and after 5 there are 2 zeros, so there is only 1 significant digit and it is 5. So these 2 zeros are not significant digits, only this 5 is significant digit. And in F, it is 5.00 into 10 to the power 2. Now there is a rule. It is given if it is written in scientific format, like the rule number 2 says, all digits in the coefficient of scientific notations are significant, but those digits in the base and the power are not significant. So here, considering that rule, only this 5 and these 2 zeros are of significance, and this 2 is not significant, and also the 10 to the power 2, both 10 and 2 have no significance. So the number of significant figures in this case will be 3. and it is 5, 0, 0. So if you see these two problems, that is E and F, here it is 500 and the next one is 5.00 into 10 to the power 2. Both are equal, both are 500. But since it is written in scientific format, it has all significance. That is all three 5, 0, 0. They have significance and they are significant digits. But here only 5 is the significant digit. So in this case, E, there is only one significant digit, but in case of F, there are 3 significant digits. Is it clear to all of you? Yes. Do anyone of you have doubt any?
No, sir.
So let's discuss it again. Now the problem says give the number of significant figures in each case and identify the rule used for each conclusion. Now in first case, it is 5.87 and it has no zeros. So here all three have significance. So in A, all the three. So in A, it is 5.87 and all the three digits 5, 8 and 7 are significant figures. Now, when you consider B, it is 0.031 and according to the rule, when there is a decimal included, all the leading zeros before any non-zero digit are of no significance. So only significant digits are 3 and 1. That is, it has two significant digits. Now, when you talk about 5, C, it is 52.90. It has decimal number, but the last zero is after the non-zero digits. So all four of them have significance, and it is 5, 2, 9, and 0. All four of them have significance. And in D, it is written 0.2001, and it is a decimal number. So before this 2, the first 0 is not significant digit. However, all these other digits as 2001, they are significant figures. And so D has 4 significant figures. And similarly in E and F, since it has 2 zeros after the non-zero digit, the significant digit is 5 only. But here, since it is written in scientific format, that is 5.00 into 10 to the power 2. So all these digits in the coefficient, that is 5.00, 5 and 2 zeros are of significance and they are significant figures. So I think it is clear to all of you. And similarly, there is another problem which says give the number of significant figures in each case. So can anyone tell me in A, what will be the number of significant figures? Anyone? Can you see my screen properly, or is there any issue?
Three significant figures.
Yes, there are 3 significant figures because according to the rule, if there are all non-zero digits, then they are all significant. So when we are considering 36.7 meter, there are all non-zeros. So the significant digits is 3 and they are 3, 6, and 7. Similarly, in B, can anyone tell me what are the number of significant figures?
Four.
Yes, it's 4. Can we explain how it is 4? So according to the rule, it is a decimal number and all the leading zeros before any non-zero. So when we are writing it 0.006140, these 3 zeros, these are leading zeros and they are not significant. And all these 4 have significance. So the number of significant digit in this case is 4 and they are 6, 1, 4 and 0. Similarly, in C, so and in C it is 804. Since there are no zero in between the two non-zero digits, so all 3 of them are significant, and the number of significant digit is number of significant digit in this case is 3, and they are 8, 0, and 4. And in case of D, can anyone tell me it is 3800 gram, but this 3 is a comma, it is not a decimal sign. So when we are considering about the rule, can anyone tell me what will be the number of significant digit in this case in D? So in D, since there are no decimal digits and all the zeros after the non-zero digits, that is 3 and 8, after 8 there are 2 zeros, they are not significant. So the number of significant digit is 2 in this case, and they are 3 and 8. So in A, there are 3 significant digits. In A, there are 3 significant digits because there are all non-zero. But in B, there are 7 digits, but the number of significant digit is 4 because all the 3 zeros that come before the non-zero digit 6, and it is a decimal number. And in case of decimal number, all zeros that are after the non-zero digits are significant figures, but the zeros that appear before the non-zero digit are not significant. So the number of significant figures in this case is 4 and they are 6140. And in case of C, it is 804 kg and the 0, since the 0 is written in between 8 and 4, this 0 is significant figure and the total number of significant figure in this case is 3, which are 8, 0 and 4. And in case of D, it is 3800 gram. So the number of significant figures in this case is 2 because these 2 are written after 8 and they are not significant. But if we can write, if we are writing it, so again, if we write it, suppose I will be writing it 8.00 into 10 to the power 2 gram. So can anyone tell me in this number what will be the number of significant digits and what are they? Anyone? So as you can see, it will be quite difficult for me to stop my discussion and to allow you to into the meet. So I request all of you to. I am basically giving you 10 minutes. And generally I'll be starting at 7:10 p.m. So I request all of you to join before 7:10 so that we can discuss without any disturbances. Because I was explaining and in between there is someone joining in the lobby. So I have to admit them again. So these are the three questions that I wanted to discuss with you regarding the significant figures. So when this is 3,800 gram and it has only two significant digits 3 and 8 because it has no decimal numbers and all these zeros are after the non-zero number 8. So all the zeros that are written after a non-zero digit in the number in which there are no decimal numbers, then it is of no significance. So the significant digit in this case is 3 and 8. But when you are writing it in scientific format, that is 38.00 and 10 to the power 2, then in this case, there are four significant figures and they are 3, 8, 0, 0 because it contains a decimal sign. That's why we have to consider all these four numbers as significant numbers and they are 3, 8, 0, 0. Can't understand why it is persisting. So now let's discuss about another measuring device that is slide calipers. So as you can see in the screen, This is a figure of a slide caliper that is generally used for more precise measurements in meter scale rather than meter scale, because in meter scale, as we saw, the least count is 0.1 centimeter, or in some meter scales it is 1 mm, or in some meter scales there are a little bit more precise measurement and it is 0.5 millimeter. But when you are intended for more precise measurements than these digits, that is 0.5 millimeters, if we are measuring something which is less than 0.5 millimeter, then we can measure it using the meter scale. But when we are using slide calipers, then we can measure it with more precision, because the least count of the device is less than that of the meter scale. So can anyone tell me what is the least count of a device? If we are saying about a device, what is called as the least count of the device? Anyone? So basically, least count of a device is the minimum measurable quantity by that device. That is, if the meter scale is of least count 1 mm and we are measuring something which is of length less than 1 mm, so we can't measure that with the help of meter scale, because in the meter scale we can measure minimum 1 mm with the actual accuracy. So when we are measuring when you are measuring something which is very thin and its dimension is less than 1 mm, then we should use some other measuring device. So slide calipers is one. So this shows the different components of a slide caliper. So as you can see, this is known as internal jaws, and basically this is used to measure suppose we are trying to measure the inner diameter of a hollow cylinder. Then what we will do? So we will place the hollow cylinder between, suppose this is a cylinder. So we will place the internal jaws in between the two walls of the cylinder, so it can measure the internal diameter of the cylinder. And similarly, if there is a quantity, suppose there is a small ball, so we can measure it by placing here, and these are measured with the help of external jaws. And this is a locking screw. So since we will be sliding this towards this side, when we are measuring something, we'll be sliding this. So this locking screw is used to tighten that measurement point. And there are two scales here. One is in inch and another in centimeter. So inches and feet are called as imperial scale, and it is metric scale. Meter, centimeter are called metric scale. And another thing that we want to measure, it is depth measuring blade. So suppose there is a groove-like structure. So if you place this portion in this groove, then we can say the height of the groove. So these are the components and their utilities to measure different parts. And now considering about the least count or vernier constant. Now in a slide calipers, there are two scales. This scale is known as linear scale. This upper scale is known as main scale, and this below one known as vernier scale. And they both have different digits, and they both are of significance, because the least count of the vernier constant is given by 1 main scale reading minus 1 vernier scale reading, because since it has two scales, so the difference between the two scale will give us the minimum. And so these two scales are being used to measure the smallest value that we can measure with the slide caliper. So if you see, generally what happens, the least count is calculated by this format: 1 main scale reading minus 1 vernier scale reading. That is, main scale reading means the minimum distance that a main scale can measure, and the vernier scale reading is the minimum distance that a vernier scale can measure. So when we will be calculating it, so the main scale reading is how much? Since as you see, in between 0 and 1 there are 10 digit, 10 marks. So the minimum measurable length by the measuring the main scale is 0.1 centimeter. So the main scale reading is 0.1 centimeter. Now this vernier scale, as you can see, these 10 divisions is equal to 9 division. However, it is not 9 accurately because it has some zero error. But if you place this so that these two zero align with each other, then it will be corresponding to this 9. So 10 vernier scale division corresponding to 1 main scale division. So the 1 vernier scale division will be how much? It will be 9 by 10 into 1 main scale division. So it will be 0.1 centimeter minus 0. How much? It will be 1 centimeter minus 0.09 centimeter, because this one main scale is 0.1. So let me write it once again. So it will be 9 by 10 into 0.1 centimeter. So it will be how much? It will be 0.1 minus 0.09. So it will be how much? It will be 0.01 centimeter. Is that clear? And also this 0.01 centimeter is how much? It will be 0.1 millimeter. So the least count of this vernier caliper is 0.1 millimeter. Since here the 10 divisions of vernier scale is coinciding with 9 division of main scale. So in this way, if we calculate, the least count will be 0.1 mm. Also, there is another method for calculating least count, which is also called as vernier constant or VC. And it is 1 main scale division divided by number of vernier scale division. So here 1 main scale division is how much? It is 0.1 centimeter, and number of vernier scale division is 10, because this 10 division corresponds to 9. However, this formula we can't apply in all. This formula we can't apply in all cases, because this formula is mainly for, suppose the vernier scale, the n number of divisions of vernier scale coincides with less than 1, that is n minus 1 division of main scale, then in that case we can write it like that. However, there are some other cases, there are a few problems I'll be discussing with you regarding this issue. So there are some other problems we will be solving, and we will be applying some other methods to measure the actual reading. So here also, if you see, it will be 0.01 centimeter or 0.1 millimeter. And the measurement value, how to measure a particular thing. So the measurement value will be main scale reading plus vernier scale reading into vernier constant, because vernier scale reading means what is the vernier scale reading? The vernier scale reading is the number of divisions of the vernier scale that coincides with any one division of the main scale. So we'll be solving few problems, and I will be telling what is the actual thing. And also there are zero error associated with the measurement. The zero error means if the device is not correct, then when we will be aligning the two scales, the zero of the two scales will not be coinciding with each other. In that case, we can say that there is zero error in the measurement device. So there are two types of zero error. One is positive zero error, another negative zero error. And as you can see, in this case, in the last case, as you can see, the zero of main scale and the zero of vernier scale both are coinciding with each other. So this is the case of zero error. However, in this case, the main scale reading and the vernier scale reading does not coincide with each other in both cases, and in both cases there are some non-zero errors. However, the errors are positive and negative, which depends upon the fact that whether the vernier scale 0 lies above the 0 value or below the 0 value. When it is lying above the 0 value, that is the vernier scale reading is positive, so it is positive 0 error. And when when the vernier scale 0 is lying below the 0 value, that is negative value of the main scale, then it is negative 0 error. So these are the two types of 0 error that is involved. And when we are measuring some value and the measurement device has some 0 error, then that 0 error is subtracted from the actual measurement value to get the correct reading of the measurement. So now let's discuss a few problems regarding the slide caliper measurements using slide caliper. Now the problem says diameter of a steel ball is measured using a vernier caliper which has divisions of 0.1 centimeter on its main scale and 10 divisions vernier scale match with 9 divisions of the main scale. The three measurements are given in this table. The actual measurement of if the zero error is minus 0.03 centimeter, the mean corrected diameter is what? So here, as you can see, the zero error is minus the zero error is minus 0.03 centimeter. That is, it has negative zero error, and also the which has divisions of 0.1 centimeter in the main scale, and the 10 division of the vernier scale coincides with 9 division of the main scale. And there are three measurements given, and we want to find the mean corrected diameter. So these are the four options. I will give you 3-4 minutes to solve this, and after that I will solve you for you. So please try to solve this. Can anyone tell me what will be the mean corrected diameter of the measurement of the steel ball? Anyone who has solved it?
0.58 centimeter.
Okay. Anyone? Any other? So let's discuss the problem. Now it is given the diameter of the steel ball is being measured using a vernier caliper, which has division of 0.1 centimeter on its main scale. So in the case, first we want to calculate the least count, and since as you can see the main scale has division of 0.1 centimeter, so the least count which stand for the least count is 1 main scale reading minus 1 vernier scale reading. So here it is given 0.1 centimeter. So the main scale reading is 0.1 centimeter, and the vernier scale reading will be how much? 9 divisions of main scale coincides with 10 divisions of vernier scale. So the one vernier scale reading will be how much? Similarly, that we had calculated, it will be 9 by 10 into 1 main scale reading. So it will be 0.1 centimeter minus 0.09 centimeter. So it will be 0.01 centimeter. So the least count is 0.01 centimeter. Now there are three measurements. The first measurement, the main scale. Now the measurement is total measurement will be how much? Main scale reading plus vernier scale reading, and vernier scale reading is how much? So the measurement value, as you can see here, the measurement value is main scale reading plus vernier scale reading into vernier constant. Vernier constant is these VS divisions means these are the vernier scale readings. That is, these divisions of vernier scale is coincide with any one division of the main scale. So here it is 4, 6, and 5. So there are 3 readings. Now the measured value will be how much? Measured value will be the value of the measurement will be main scale reading plus vernier scale reading. So main scale reading is 0.5 plus vernier scale reading will be how much? Vernier scale division into least count. It is 0.01 centimeter. So it will be how much? In first case, 5 plus 0.04 centimeter. So it will be 0.54 centimeter. So in the first measurement, the measured value will be 0.54 centimeter. Similarly, in the second measurement, it will be how much? Since the vernier scale division is 6, it will be 0.56 centimeter. And in case of this third measurement, it will be 0.55 centimeter. So all the three observations, when an observer is taking measurement, see, here she has measured 3 times, and each time the vernier divisions are different. So according to this vernier division, the readings are different, and the reading is 0.54 in first case, in second case it is 0.56, and in third case it is 0.55. Now, since there are three observations, so we need to calculate the mean. So the mean observation will be how much? Mean observation will be 0.54 plus 0.55 plus 0.56 divided by 3. It will be how much? It will be 0.55 centimeter. So this is the measurement with the slide calipers. However, as you can see, the slide calipers have zero error of minus 0.03. So since it has a zero error, so the actual measured value will be how much? The actual value will be value minus zero error. So the measured value is how much? Measured value is 0.55 centimeter. 0.55 centimeter minus the zero error is in this case 5 minus 0.03 centimeter. Since it is negative, so it will be minus 0.03 centimeter. So the total will be 0.55 plus 0.03. It will be 0.58 centimeter. So this is the answer. The answer, the mean measurement of the 3 observations is 0.58 centimeter. Is there any doubt in this question? Is it clear to you, or I need to explain it again? So basically what we did in this problem, whenever there is no list count given in the problem, we first need to calculate the list count of the measuring device. So here in this case, since the main scale division is given as 0.1 centimeter, the main scale reading is given as 0.1 centimeter. So the least count of the main scale is 0.1 centimeter. Now we want to calculate the least count of the vernier scale, and it is given the 10 divisions of the vernier scale corresponds to 9 division of the main scale. So since 10 divisions of the vernier scale equal to 9 division of main scale, so 1 division of vernier scale will be 9 by 10 divisions. So when we are converting into main scale division, then main scale division 1, main scale division will be multiplied to it. And as in previous case, we calculated the least count. So in this case also, the least count will be 0.1 centimeter minus 0.09 centimeter. It will be 0.01 centimeter. So the total measuring value will be how much? Main scale reading plus vernier scale reading. Vernier scale reading consists of vernier constant and the least count of the vernier scale. So main scale reading is 0.5 centimeter, and the number of division that coincides with the vernier scale is the number of division of the vernier scale that coincides with the main scale division is 4. So 4 will be multiplied with the least count. So the total measurement value will be 0.54 centimeter. Similarly, in the second case, it will be 0.56 centimeter, and in the third case, it will be 0.55 centimeter. So since we have taken 3 measurements, so the mean measurement will be sum of the 3 divided by 3. So it will be 0.55 centimeter. So this is the measurement that we have performed. So this is the measurement, but the actual measurement depends upon the measurement that will be obtained after subtracting the zero error, because the measurement device has some zero error, and this zero error is minus 0.03 centimeter. So the actual value will be measured value divided subtracted. We'll be subtracting zero error from it. So it will be 0.55 minus, since the zero error is negative, so it will be added again. So it will be 0.58 centimeter. So the mean corrected reading of the ball is, the diameter of the ball is 0.58 centimeter. towards our next question. Now this question says the diameter of a cylinder is measured using a vernier caliper with no zero error. It is found that the zero of the vernier scale lies between 5.10 centimeter and 5.15 centimeter of the main scale. The vernier scale has 50 divisions equivalent to 2.45 centimeter. 50 divisions equivalent to 2.45 centimeters of the main scale, and the 24th division of the vernier scale that exactly coincides with the one of divisions of the main scale. Now we need to find out the diameter of the cylinder. So I would like to read out the question again. Now the question is, we are measuring the diameter of a cylinder using a vernier caliper, and the vernier caliper has no zero error, and it is found that when we are measuring, the zero of the vernier scale lies between in corresponding to main scale, the zero of the vernier scale lies between 5.10 centimeter to 5.15 centimeter. And the vernier, and regarding the vernier scale, it is given the 50 divisions of the vernier scale is equivalent to 2.45 centimeters of the main scale. And the 24th division of the vernier scale, since the vernier scale has 50 divisions, the 24th division of the vernier scale exactly coincides with one of the main scale division. Now we want to find out the diameter of the cylinder. So this is a bit of tricky question. So I will be giving you a few minutes to solve this, and after that I will solve. So please try and tell me the answer. Did anyone solve it? Can anyone tell me what will be the answer? Anyone? So there is a trick in this question, and the trick lies between the fact that it is found that the zero of the vernier scale lies between 5.10 to 5.51 centimeter of the main scale. So if you see this portion of the question, it is given when we are measuring the zero of the vernier scale. Suppose this is the zero of the vernier scale. Then this zero of the vernier scale lies between 5.10 and 5.15. So this is 5.10 and this is 5.15. So for a main scale, there are no other divisions between 5.10 to 5.15. So main scale reading in this case becomes 0.05 centimeter. So this is the fact. So since the vernier scale lies between 5.10 and 5.15 centimeter, so in between 5.10, 5.10 and 5.15, there are no other divisions. So we can't measure. So you can't measure precise reading. The least reading that we can measure is 0.05 centimeter. So in this case, the main scale reading is 0.05 centimeter. So we want to calculate the vernier scale reading. Similarly, the vernier scale reading will be how much? Because in order to calculate the least count, we need main scale reading and vernier scale reading. Now, as you can see, it is given 50 division. The vernier scale has 50 division, and 50 divisions of the vernier scale is equivalent to 2.45 centimeter of the main scale. But in the previous case, what we are saying? We are saying that 10 divisions of the vernier scale equivalent to 9 division of the main scale, and each division of the main scale is 0.1 centimeter. But here in this case, 50 divisions of the main scale is equivalent to 2.45 centimeters. So the vernier scale reading will be how much? The vernier scale reading will be, since 50 division corresponds to 2.45, so one division of the vernier scale will be 2.45 by 50 centimeter. So the least count of the device will be how much? The least count will be 0.05 minus 2.45 divided by 50. So it will be how much? It will be 0.050 minus 0.049. It will be 0.001 centimeter. So the least count of the vernier scale or vernier caliper that we are using in the problem is 0.001 centimeter. So also from the answer you can guess it, because in the answer there are 3 digits after the decimal sign. So it is obvious to say that the least count of the device is 0.001 centimeter. Now we want to calculate the actual measurement. Now since here the main scale reading is how much? Since the vernier scale lies between 5.10 and 5.15, the main scale reading is 5.10 because the vernier scale lies somewhat here. So main scale reading with the accuracy, we can determine up to 5.10. So in this case, the main scale reading will be 5.10 centimeter. Now we need to calculate the vernier constant. Now here in the question it says 24th division of the vernier scale exactly coincide with any one division. So the vernier scale division is 24. So when we are calculating the value, so the measured value will be how much? The measured value will be main scale reading plus vernier scale reading. So main scale reading is 5.10 centimeter plus vernier scale reading is 24. This is the vernier divisions and the least count. The least count is 0.001 centimeter. So it is 5.100 centimeter plus 0.024 centimeter. So it will be 5.124 centimeter. So this is the answer, and this is the measured value of the. Here the zero error is absent, so there is no zero error. If there are zero error, then we must be subtracting the zero error from the measured value. Since in this question, as you can see, the question says the vernier caliper has no zero error. So the measure value is the correct value, and the measure value is 5.124 centimeter. So is it clear to all of you? Is it clear to all of you, or I need to explain it again? If you see the question, the vernier caliper which is being used for the measurement has no zero error, and the zero of the vernier scale lies between 5.10 to 5.15 centimeter of the main scale. So since after 5.10 centimeter, we are directly measuring 5.15 centimeter with the help of main scale. So the minimum measurement that can be performed with the help of main scale is 0.05 centimeter. Now, regarding the vernier scale has 50 divisions, and this 50 division is equal to 2.45 centimeter. So since 50 division is equal to 2.45 centimeter, one division will be equal to 2.45 by 50 centimeter, and by subtracting the two readings, that is main scale minimum distance measured by main scale and minimum distance measured by vernier scale, the least count can be obtained, and the least count is 0.001 centimeter. So since the vernier zero lies between 5.10 and 5.15, the main scale reading in this case of measurement is 5.10, and when you are adding the vernier scale reading, the vernier scale reading will be how much? The vernier scale reading will be vernier divisions into least count, and here 24th division of the vernier scale lies exactly with any one of the main scale division. So it will be 24 into least count. So 24 into least count will be, so 24 into least count will be 24 into 001 centimeter. So the total measured value will be 5.124 centimeter. Since in the measurement there are no zero in the measuring device, that is the vernier caliper, there are no zero errors. So in this case, the measurement is the actual measurement value, and we don't need to subtract any zero error. So the actual measurement value is 5. The answer will be 5.124 centimeters. So option 2 is correct. To our sixth question of the day. Now the question is, there are two vernier calipers, both of which have 1 centimeter divided into 10 equal divisions on the main scale. But the vernier scale of the caliper C1 has 10 equal divisions that corresponds to 9 main scale division. The vernier scale of the caliper C2 has 10 equal divisions that corresponds to 11 main scale divisions. The readings of the two calipers are shown in the figure. The measured values in centimeter given by the calipers C1 and C2 respectively are these. So in this question, what is given? Question says there are two vernier calipers that are C1 and C2, and since it is a vernier caliper, it has main scale and vernier scale, and in both the cases C1 and C2, as you can see, the main scale is divided into 1 centimeter is divided into 10 equal divisions of the main scale. but the difference lies between the vernier scale division. In case of C1, 10 divisions of the vernier scale corresponds to 9 main scale division, but in case of vernier 2, 10 divisions of the vernier scale corresponds to 11 main scale divisions. So there is the difference. For one case, 10 division equal to 9 main scale division, but in the second case, C2, 10 division equal to 11 main scale divisions. So the readings measured by both the calipers will be different. So we want to find the readings of the measurement, and these are the options. So I'd like you to try this question. It is a very good question. So try this question, and I'll be giving you a few minutes to solve this. And after that, I'll be solving for you.
Answer 2, sir.
Sorry, once again. What is the answer? Correct option is, you are saying 2. Sorry, I think there is a mistake. It is 1, 2, 2. You can say which one of this. Suppose it is A. I am correcting it. This one is 1, 2. This is 3. This is 4. Which is the correct answer you are saying? Yes. Solve this question. Actually, there is a trick in this question. The trick is, in case of C1, it is pretty much convenient because 10 equal divisions corresponds to 9 main scale division. Like in the previous questions, we are calculating least count, and it was 1 main scale reading minus 1 vernier scale reading. So in this case, it will be 1 minus 9 by 10. So it will be 0.01 centimeter. And if we compare, in case of C1, the reading is 2.8. If the main scale reading is 2.8, and the seventh division corresponds to coincide this one. This seventh division coincides with any one of the division of the main scale. So it will be 0. So it will be 2.8 plus 0.07. So it will be 2.8 plus 0.07, that is 2.87 centimeter. But if this same thing, if we apply for C2, it will be 1 minus 11 by 10. So it will be minus of 0.01 centimeter. But it can be possible because least count should be positive. So in this case, since the 10 division of the main scale, 10 division of the vernier scale correspond to 11 division of the main scale. In this case, this formula that we are using in previous problems, it will not be applicable here. So you will be applying another formula, and that is what the measurement value is the main scale reading that coincides with any one division of the vernier scale, and we will subtract that from that value. We will subtract the reading of the vernier scale. So what we do? We will be in first case. If you see in first case, here it coincides with 3.5 and here it coincides with 3.7. This is 3.7. So here in first case, case 1 will be how much? So in case 1, the measurement value will be 3.5 minus, because here 3.5 coincides with the vernier division. It will be 3.5, and which vernier division coincides with 3.5? 1, 2, 3, 4, 5, 6, 7. So this 7th vernier division coincides with the 3.5. The vernier division will be 7. But here we want to, since it is 7, we need to multiply 7 with some division, with some number which corresponds to vernier scale. So we need to first calculate the vernier scale division. So in first case, 10 main scale division corresponds to 9 vernier scale division. So it will be, so one vernier scale division will be how much? It will be 9 by 10 into main scale division. So it will be 0.09 centimeter. So in the first case, the measurement will be 7 into 0.09 centimeter. It will be 3.5 minus 0.63. It will be 2.87 centimeter. And this 2.87 centimeter we are also getting in with the help of previous way of calculating. But in second case, when you calculate, it will be different because it was coming to be negative. The least count was coming to be negative. But here, as you can see, in the second case C2, if we calculate, similarly, what will be? In the second case C2, the main scale reading is how much? It is 3. How much? It is 3.6. As you can see, 3, 1, 2, 3, 4, 5, 6. So 3.6, the 6th division after 3 coincides with the main scale division. Which vernier scale division? 1, 2, 3, 4, 5, 6, 7. So 7th division of the vernier scale coincides with 6th division of the main scale. So here it will be 3.6 minus 7 into, there will be some value. So here that value will be how much? Here that value will be, like in previous case, it was 0.09, because in that case, 9 vernier scale division correspond to 10 main scale division. But here, since 11 division correspond to 10 main scale division, so it will be 11 by 10. It will be 0.11 centimeter. It is 0.11 centimeter. So here the number will be 0.11. So it will be how much? 3.6 minus It will be 3.6 minus 0.77. It will be how much? It will be 2.83 centimeters. So in first case, it will be 2.87 centimeter, and in second case, it will be 2.83 centimeters. So this will be the correct answer. So I would like to calculate this. So in this question, the question was, we are measuring with two vernier calipers. Both the vernier calipers have 10 divisions between two numbers, that is 1 centimeter is divided into 10 divisions, but the vernier scale has different calibrations. For C1, 10 divisions of the vernier scale corresponds to 9 main scale division, and in case of C2, 11 main scale division corresponds to 10 vernier scale division. So the vernier scale reading in both the cases are different, but the main scales are same. So the method is different here for calculating the measurement value. So when you are calculating in previous cases, in first case we can apply, because the least count will be 1 minus 9.10 into main scale reading. Main scale reading is 0.1 centimeter. So 9 by 10 into 0.1 is 0.09. So the least count will be 0.01 centimeter. And according to the rule of measurement, the measurement is 2.8, and the 7 division coincides with the main scale division. So it will be 2.87. But since in second case, 10 division of vernier scale corresponds to 11 division of main scale, the least count it becomes negative. So we can't apply the method for second case. So we will be applying different method, and that method consists of, the actual measurement will be the main. Here you are calculating vernier scale reading that coincides with main scale, but here we will be taking main scale reading that coincides with the vernier scale. So in this case, if you see in the first case, this 3 in the first case, this 3.5 coincides with 7 division of main scale, and for first case, one main scale division is 0.9, as you can see. So for first case, it was, so for first case, 10 vernier division corresponds to 9 main scale division. So one vernier division will be 9 by 10 main scale division. So 9 by 10 into main scale division is 0.1 centimeter. So it will be 0.09 centimeter. But in second case, this 10 vernier division was corresponding to 11 main scale division. So it will be 1 vernier division, 11 by 10 main scale division. So 11 by 10 into 0.1, because main scale is equal in both cases. So it will be 0.11 centimeter. So one vernier division corresponds to 0.09 centimeter in first case, but in second case, this is C1, this is C1, and this is C2. So for C1, one vernier division is 0.09 centimeter, but for C2, one vernier division is 0.11 centimeter. So according to the new measurement rule, it will be main scale division minus, like in calculating least count, we are calculating one main scale division minus one vernier scale division. Here we will be calculating total main scale division minus total vernier scale division. So the total main scale division is 3.5, and since the 7th vernier division is coinciding with 3.5 in this case, as you can see, 7th vernier division coincides with 3.5. So it will be 3.5 minus 7 into this 0.9. The 0.9 is coming from here. And similarly, since in this case, this 3.6 corresponds to 7 division of the vernier scale, so it will be 3.6 minus 7 into 0.11. This 0.11 corresponds to what? This 0.11 corresponds to 1 vernier division. So 1 vernier division is 0.11 in C2 case. So it will be 3.6 minus 0.77. It will be 3.5 minus 0.63. So it will be 2.87 and it will be 2.83. So these are the two measurements. This is a very interesting question. So I would like you to understand this question very carefully, because this type of question can come in your exams when you are appearing for the exam, and these are very good questions from the level point of view. These questions are really good because in this question, what was the discrepancy? The discrepancy was between the divisions of main scale and vernier scale. In first case, the in first case, 9 division was equal to 10 division of vernier scale, but in second case it was 11 division. So since the divisions are different, so in vernier scale, the vernier scale division in both the cases are different. For first case, one vernier scale division was 0.09 centimeter, but in second vernier scale it was 0.11 centimeter. So we multiplied 0.09 centimeter in first case, and in second case we multiplied 0.11 in second case we multiplied 0.11. So these are the two answers. So the correct answer will be 4, that is 2.87 and 2.83. However, if you see, both the measurements look pretty much similar, because as you can see here, it is C1 is 2.8 and here it C2 is 2.8. But the discrepancies lies between the vernier scale divisions and their calibration. Is it clear to all of you? So we'll solve next question. This question is very easy question. Now the question says, if a vernier caliper one main scale division is x centimeter and n divisions of the vernier scale coincides with n minus 1 division of the main scale, the least count in centimeter of the caliper is. So this is a very easy question, but the variables are different here. So you will be solving it in terms of x and n, because x and n is given. So in one main scale division is x centimeter and n divisions of the vernier scale coincides with n division of the vernier scale coincide with n minus 1 divisions of the main scale. So we want to calculate the least count. So I will be giving you a 1 or 2 minutes for this question because it is a very easy question, and after that I will be solving it. Can anyone tell me what will be the answer? This is a very easy question. The question is, in the previous questions, we are calculating least count is 1 main scale reading minus 1 vernier scale reading. So here it is given 1 main scale reading is how much x centimeter, because 1 main scale division is x centimeter. So it is x minus vernier scale reading is calculated how? It is given as n divisions of vernier scale coincides with n minus 1 division of main scale. So it will be how much? It will be n minus 1 division of the main scale corresponds to n division of vernier scale. So 1 division of vernier scale corresponding to n minus 1 by n division of main scale. And for main scale, the main scale, 1 main scale division corresponds to x centimeter. So it will be, if you take x common, it will be 1 minus n minus 1 by n. It will be x into n minus n plus 1 by n. It will be x by n. So the answer, this is a very easy question, but only the difference is the variables are given in terms of x and n. There are unknown variables and we want to calculate the least count. So the least count in this case is main scale reading minus vernier scale reading. Main scale division is x centimeter, so minimum length that can be measured is x. And in case of vernier scale, since n divisions of vernier scale coincides with n minus 1 division, then 1 division of the vernier scale will be equal to n minus 1 by n division. And in terms of main scale, it will be into x. So when you calculate the sum or difference, it will be x by n. So the least count will be x by n centimeter. Sometimes the question becomes tricky when it is written that the least count in mm. So after calculating in centimeter, you have to convert it to mm in order to say the. So can anyone tell me what will be the least count in here? The least count is x by n centimeter. So what will be it in mm? How much mm? Anyone? If you convert centimeter into millimeter, what do you do? So we will simply multiply 10. So 10x by n into millimeter. So now let's discuss about screw gauge. Screw gauge is another type of measuring device, and it is used for more precise measurement. It is a bit of more precise in comparison to slide calipers, because in some slide calipers the measurement is 0.01 centimeter or 0.1 millimeter, but in screw gauge we can measure up to in standard screw gauge we can measure up to 0.005 centimeter. That is the least count of the screw gauge is half of the least count of the vernier scale. So there are different components of the screw gauge. So this is anvil and spindle. These are used to hold the object. If you are measuring some object, the object will be placing in between the two portion. So if you are measuring something, the object will be placing here. So this is the linear scale. Like in vernier caliper, there was two scales. One was main scale, another was vernier scale. Here there is also two scales. One is main scale and another is circular scale. These are it is pretty much similar to the vernier scale, but it is circular in shape, and it has now some different number of divisions. Since it is circular in shape, so generally it has more number of divisions. In vernier scales, so you can find at most 50 divisions, but in case of circular scale, we can find up to 100, up to maybe up to 200 divisions per one circular scale. So this is the thimble which is used to rotate to move it to this side, and this is the ratchet which is used to tighten. So after placing that object, when you can't move the thimble, then ratchet provides you more precise movement. And if you rotate it and it makes a sound, generally it is if after making 3 times of the sound, then you should stop and it is perfectly tightened. So this is the way of measurement using screw gauge. Now, generally, since it is a circular scale, and there is a quantity which is known as pitch of the screw gauge, and that pitch of the screw gauge is distance moved by a screw up and number of rotations given. Since that generally, if you are talking about pitch is the number of rotations, the circular scale, the amount of distance that the circular scale moves on the main scale after one rotation. So the distance moved by the screw, suppose the main scale is somewhat here, but after one complete rotation, it comes to here. So this distance, the distance between these two lines will give the pitch of the screw. That is, after one complete rotation, how much it is proceeding in main scale. So with the help of pitch, we can calculate the least count. Since there are more than there are large number of divisions in the circular scale, and when we divide pitch with the number of divisions of the circular scale, we will calculate the least count of the screw gauge. So, and the measurement value, what is the measuring value? Measurement value will be linear scale reading plus circular scale reading and minus 0 error. So suppose here it is, so the main scale reading will be how much? So it is 1, 2, so it is 2 point, so it is 2.5 mm. So main scale reading 2.5 mm, and that coincides with this 45 or 46. So 46 will be circular scale reading, and this 46 into the into least count will give a circular scale reading. 46 is the circular scale division. When you multiply it with least count, it will give us a circular scale reading. And if there are any 0 errors, then we will subtract that 0 error. So there are similarly in case of slide caliper, there are 0 errors. In case of screw gauge, there is also 0 error. In the first case, you can see this is main scale or linear scale, or it is circular scale. This is linear scale and this is circular scale. When the 0 of linear scale and when the 0 of linear scale and 0 of circular scale coincides with each other, then it is called as no 0 error. And if the 0 lies above the circular scale 0, then it is positive 0 error because it is lying at 5. And when it is lying below the 0 value of the circular scale, it is negative 0 error. So these are the three types of errors. So now let's solve our first question regarding the screw gauge. And the question says, a screw gauge with a pitch of 0.5 mm and a circular scale with a 50 divisions is used to measure the thickness of a thin sheet of aluminum. Before starting the measurement, it is found that when two jaws of the screw gauge are brought in contact, the 45th division coincides with the main scale, and that the 0 of the main scale is barely visible. What is the thickness of the sheet if the main scale reading is 0.5 mm and 25th division coincides with the main scale line? So it says, let's read it again. The pitch of the main scale is 0.5 mm and the circular scale has 50 divisions. So since the pitch of the so we know least count is pitch. Least count is pitch by number of division in the circular scale. It is given pitch 0.5 mm and number of division in circular scale is 50. So this screw gauge is being used to measure the thin sheet of aluminum. And before starting the measurement, it was found that two jaws of the screw gauge are brought in contact. The 45th division coincides with the main scale line, and the 0 of the main scale is barely visible. So this 45th lies with 0. So as you can see here also, the 45th is coinciding with 0. So in this case, there is negative 0 error. So this is the negative. So the screw gauge has some error, and this is negative 0 error because the 0 of the main scale coincides with 45 division of the circular scale. And during the measurement, the main scale reading is 0.5 mm and 25th division coincides with the main scale. That is 25th division of the circular scale coincides with the main scale. So I'll be giving you a few minutes. So please try to solve it. And after that, I will solve it. Let's solve this question. So it is given the screw gauge with a pitch of 0.5 mm. So the least count will be how much? Least count will be pitch by number of divisions. So the number of division is 50 and the pitch is 0.5 mm. So it is 0.5 by 50. So it will be 0.01 mm. So the least count of the screw gauge is 0.01 mm, and since the 45th division coincide with 0, so the 0 error is negative, and that negative 0, since it is 50 and it is 45, so the 0 error will be minus 5 into 0.01, that is the least count. Minus 5 into 0.01, that is minus 0.05 mm. So the 0 error is negative and it is 0.05 mm. And now during the measurement, it is found that the main scale reading is 0.5 mm. So during the measurement, the measured value will be how much? The measured value will be main scale reading plus circular scale reading minus 0 error. So the main scale is how much? The main scale is 0.5 mm. So the value will be 0.5 mm stands for main scale reading. And for circular scale reading, it is given 25th division coincides with the main scale. So for circular scale, it will be how much? 25 into least count minus the 0 error that is present in the device. So it will be 0.5 mm into, sorry, plus will be added 0.5 plus 25 into least count is 0.01 mm, 0.01 mm minus 0 error is minus 0.05 mm. So it will be how much? 0.5 plus 0.25 plus 0.05. It will be 0.80 mm. So this is the answer. The answer, and the measured value is 0.80 mm. So the question was, the screw gauge has a pitch of 0.5 mm and the circular scale has 50 divisions. So when you calculate the least count, it will be 0.5 by 50. So it is 0.01 mm. And this screw gauge is being used to measure the thin sheet of aluminium. So the before starting the measurement, the initial before starting the measurement, initial reading was 45th division coinciding with 0. So since 45th division, that 45th division is lying below the 0 of the circular scale. As you can see in this case, it is negative 0 error. So the measurement, so the device has negative 0 error and it is 0.5 mm. So the measured value will be main scale reading plus circular scale reading plus minus 0 error. So the main scale reading is 0.5 mm. It is given in this question. Main scale reading is 0.5 mm, and the 25th division coincides with the circular scale. So it will be 25 into. It will be 25 into least count. Least count is 0.01 mm. So it will be total 0.5 plus 0.25, 0.75 mm. But when we are subtracting the negative 0, it is being added. So it will be 0.75 plus 0.05. So the total measurement value will be 0.80 mm. So these are the questions that we are able to discuss in the today's interaction section. So is there any doubt Anyone? You can ask me. When I'm explaining, if you have doubt, you can stop me in between and ask your doubt. So, okay. Thank you all for joining today's session. In the upcoming session, we will be discussing a few more problems regarding the measuring device like screw gauge and other like galvanometer and how the galvanometers are being used as voltmeter and ammeter, and we'll be solving few problems regarding this. So thank you again. Thank you all for joining the today's session. That's it.
Thank you, sir.
Thank you, sir.
Okay. Good night.
Thank you, sir.
Where we got PDF, sir?
About this of this PPT.
Yeah, sir. Yeah.
Yeah, I'll be. I think a sheet must be shared with you. And that will be containing the details regarding the session link, that is link to joining this session, and also regarding the drive link. And in that drive folder, I'll be uploading the PDF file of the PDF version of this PPT, so you can easily get there. Is this okay?
Okay, sir. Okay.